On June 22, 1941, approximately 420,000 Soviet soldiers became casualties in 9 days during the Battle of Białystok-Minsk, a catastrophic hemorrhage that exposed the Red Army's fundamental firepower disadvantage against German infantry. The crisis originated not from inferior tactics or courage, but from a mechanical reality. Soviet riflemen armed with bolt-action Mosin-Nagant rifles could fire only 10 to 15 rounds per minute against German squads equipped with semi-automatic weapons delivering sustained suppression at combat ranges. The Wehrmacht's development of the Gewehr 41 promised to render Soviet bolt actions obsolete in defensive engagements, forcing the USSR to develop a mass-producible semi-automatic rifle capable of 30 rounds per minute in -40°C Eastern Front winters. The systematic destruction of Soviet infantry firepower that enabled Barbarossa's opening success demanded an answer that could match German volume of fire while surviving conditions that destroyed complex mechanisms. The Smolensk offensive between July 10 and September 10, 1941, demonstrated the tactical consequences of this disparity. Soviet forces suffered approximately 486,000 casualties as multiple German panzer groups encircled and destroyed major elements of 4 armies. After-action reports from the 16th Army documented the core problem: inability to suppress enemy machine gun nests due to reload delays under fire. German development programs had begun work on the Gewehr 41 semi-automatic rifle in 7.9 2x57 mm Mauser, accepted in 1941 with a 10-round magazine and 20 rounds per minute rate of fire. The weapon promised to render Soviet bolt actions obsolete in defensive engagements, forcing the USSR to develop a mass-producible semi-automatic rifle capable of 25 to 30 rounds per minute in -40°C Eastern Front winters, where both rifles required proper maintenance. If you're interested in how engineering decisions win wars through superior firepower and industrial capacity, subscribe now and turn on notifications. Let's continue. Fedor Vasilyevich Tokarev received his commission at the Tula Arms plant in summer 1939, weeks after Soviet directives mandated development of a universal semi-automatic rifle for all arms. The 61-year-old colonel engineer had spent 3 decades perfecting automatic weapons, including the TT-33 pistol that would arm Soviet officers throughout the war. Born June 5, 1879, Tokarev led a 12-man team at the Tula OKB-2 Design Bureau, competing against Sergei Simonov's AVS-36 and derivatives of the DP-27 light machine gun. His SVT-38 prototype emerged from trials in 1938, though field testing revealed reliability issues requiring improvement. The design constraints shaped every engineering decision. Weight could not exceed 3.95 kilograms. Production cost must remain competitive with the Mosin-Nagant. Manufacturing time was limited to 5.5 man-hours. The deadline demanded 25,000 units by March 1940. Tokarev chose a short-stroke gas piston over Simonov's long-stroke system, providing manageable recoil compared to the Mosin while maintaining reliability. Approximately 74 major components replaced the German G41's complex machined construction. Stamped steel construction comprised 70% of overall parts, cutting weight and assembly time significantly. The fixed 10-round magazine prevented loss in mud that plagued detachable designs. Soviet wartime logistics prioritized simplicity for illiterate conscripts, enabling Tula to achieve high output rates by July 1941. The SVT-40 chambered the 7.62 by 54 mm R cartridge, a rimmed design carrying projectiles weighing 9.6 to 11.8 grams depending on variant. Standard ball ammunition drove a steel-core full-metal jacket bullet at 830 meters per second, generating 3,400 joules of muzzle energy. Armor-piercing variants used 10.4-gram steel cores, achieving 20 mm penetration at 100 meters, 10 mm at 300 meters, and reduced effectiveness at 500 meters when tested against rolled, homogeneous armor. The complete weapon measured 1,226 millimeters in length, with a 730 mm barrel featuring 4-groove rifling at 1 in 9.45-inch twist. The rifle weighed 3.95 kilograms unloaded, 4.2 kilograms with bayonet attached. Gas operation employed a short-stroke piston, driving a vertical cam locking block with 0.3-second cycle time, enabling 25 to 30 rounds per minute in practical combat conditions. Manufacturing employed 70% stamped sheet metal, 2 forgings, and no machining operations on most components. Component count of approximately 74 major parts required 5.5 man-hours for complete assembly, compared to the Mosin Nagant's 9.2 hours. Ammunition types included T-30 ball at 830 meters per second, T-45 armor-piercing at 810 meters per second, penetrating 20 millimeters at 100 meters, PU sniper match loads achieving 0.6 minute of angle accuracy to 800 meters, and T-46 incendiary rounds capable of igniting 40 millimeter fuel tanks at 200 meter range. Production centered at 3 facilities following the German invasion. Tula Arms Plant manufactured the majority of early output until evacuation in October 1941. Izhevsk Mechanical Plant produced substantial quantities throughout the war. Evacuated factories in Vyatskia Polyany contributed additional output after 1941. Production figures revealed the weapon's industrial priority, with substantial increases through 1942, followed by declining output as other weapons received priority. Total wartime production reached approximately 1.47 million SVT-40 and SVT-38 rifles combined. Daily output reached high levels at Tula in July 1941 before evacuation. Izhevsk sustained 800 rifles daily throughout 1942, averaging 20,000 per month. Soviet wartime production costs varied significantly, with skilled workers receiving higher wages. Material requirements consumed 350 kilograms of steel and scrap per 100 rifles. Unit costs remained competitive with existing weapons while requiring significantly more resources than the Mosin Nagant, and equivalent to 400 rubles for the PPS-41 submachine gun. Assembly required 5.5 total man-hours, 2.1 for stamping, 1.8 for assembly, and 1.6 for barrel rifling, representing 40% less time than the German G-41's 14.2-hour requirement. Soviet doctrine distributed the SVT-40 as specialized weapons for squad leaders and marksmen, rather than universal infantry rifles. The 1941 Rifle Division Table of Organization allocated semi-automatic rifles to approximately 10 to 20% of rifle companies, scaling higher in Guards rifle units by 1943. Total distribution reached 300,000 to line infantry and 50,000 to NKVD border troops. Standard employment positioned SVT-40 riflemen at 200 to 400 meter range, providing fire support behind Mosin Nagant-equipped soldiers. The 1942 Combat Regulations for Infantry Rifle Platoon specified semi-automatic rifle suppression of enemy advances at 300 meters through volley fire in 3-round bursts. Combat effectiveness emerged immediately during the Moscow counteroffensive. On December 5, 1941, the 316th Rifle Division engaged the 78th German Infantry Division near Moscow. Soviet reports documented effective SVT-40 fire against German infantry at extended ranges with multiple confirmed casualties. At Stalingrad between November 19, 1942 and February 2, 1943, rifle divisions employed SVT-40s effectively against German infantry, according to available records. The 13th Guards Rifle Division recorded successful engagements using sniper variants during the February 23, 1943 engagement at Krasny Liman against 1st Panzer Army. During the Kursk offensive from July 5 to 23, 1943, the 106th Rifle Division employed semi-automatic fire to pin Tiger tank infantry screens, enabling anti-tank gun crews to achieve tank kills against 2nd SS Panzer Corps. German recognition of the SVT-40 threat began during the Smolensk battles in July 1941. German reports noted captured Russian self-loading rifles with 10-shot magazines, firing 30 rounds per minute, superior to the Kar 98K in volume of fire. By September 1941, captured examples reached German testing facilities for evaluation, influencing the Gewehr 43 development accepted in 1943. The German G41 design proved catastrophically complex with extensive machined components, weighed 4.85 kilograms, and employed a bang mechanism that failed in dirt conditions. German G41 production included the failed G41M with 6,673 rifles before abandonment. Total G41W production reached approximately 145,000 rifles, many withdrawn from service due to mechanical failures. The Wehrmacht then developed the Gewehr 43, accepted October 19, 1943, which incorporated gas operation but weighed 4.05 kilograms and suffered reliability issues in snow below 0 degrees Celsius. German tactical adaptations included Order 1943/156, dated March 15, 1943, mandating squad dispersion against semi-automatic fire. The Wehrmacht developed applique armor on Panzer IV tanks against anti-tank rifles, affecting production schedules. A captured OKH Fremde Heere Ost bulletin noted Soviet SVT-40. Effectiveness forced German tactical changes, while their G43 proved unreliable below freezing with significant stoppage rates. Soviet effectiveness reflected the weapon's tactical impact across major Eastern Front battles. Rifle divisions at Stalingrad documented substantial German infantry casualties through semi-automatic fire. Guards units achieved effective suppression at 300 to 500 meter range during the Dnieper crossing on September 26, 1943. Army-level SVT teams contributed significantly during the Rzew Vyazma operations in 1942. During the Berlin assault from April 16 to May 2, 1945, rifle divisions recorded effective employment of semi-automatic fire against German positions. Eastern Front employment demonstrated clear tactical advantages over bolt-action rifles in sustained firefights. The weapon's limitations became apparent by mid-1943 against German Panzerfausts penetrating 140 mm compared to SVT armor-piercing rounds limited to 10 mm. Full obsolescence arrived in 1944 with the STG-44 assault rifle's 600 rounds per minute rate. Secondary roles included NKVD pacification operations, claiming 20,000 casualties in Ukraine during 1944-45, and anti-partisan warfare in Manchuria during 1946. Soviet service continued until 1955, when the SKS replaced semi-automatic rifles with 300,000 SVT-40s refurbished between 1946 and 48. Post-war exports extended the weapon's service life across multiple conflicts. North Korea received rifles in 1950 seeing action during Korean War engagements. China employed captured examples during various conflicts, with the Type 56 designation referring to SKS rifles rather than SVT variants. Yugoslavia manufactured variants that saw action during the 1999 Balkans conflict. Norwegian development of the AG-42 Ljungmann incorporated SVT gas system influences. Afghanistan between 1979 and 89 featured Mujahideen captures, including the 1985 Panjshir battle, claiming 12 Soviet casualties. Modern conflicts demonstrate the design's enduring utility. Syrian rebels employed captured rifles during the Aleppo siege in 2016, achieving 300-meter sniper kills. Ukrainian forces in 2022 included various stocks, with reported Russian casualties at Bakhmut in March 2023. American civilian collectors imported 5,000 examples before the 1968 ban. German production demonstrated manufacturing challenges. G43 total production of 402,713 rifles included 53,435 scoped variants, but quality control issues resulted in significant rejection rates compared to the SVT-40's superior acceptance rate. The systematic destruction of Soviet infantry firepower that enabled Barbarossa's opening success had forced the creation of a weapon so fundamentally sound it required no improvement, only mass production. 420,000 casualties in 9 days demanded an answer that could fire 30 rounds per minute in -40-degree cold, manufactured by workers who had never built weapons before the German advance forced their education. If you enjoyed this deep dive into Soviet small arms engineering, hit subscribe for more World War II weapons analysis every week. Thanks for watching.